Okay, let me show you guys what the problem is. It's a problem with the BITX40 module inside my Hodgepodge transceiver. I discovered it this morning when I was fooling around with RTL-SDR. And so I've got the RTL-SDR fired up right now. And it's receiving off just a piece of wire that I have placed near the transceiver. I'll show you what happened. I have it lined up, and this thing is now looking at a lower sideband signal. Oh, it's about 2,700 kcs wide. And I've got it lined up so that my carrier frequency is lined up with what's supposedly the carrier frequency of the RTL-SDR dongle and HD-SDR. So watch what happens when I hit the push to talk. You can see the carrier pops up, and the carrier is right where the 0 beat line is with the RTL-SDR dongle and the HD-SDR. Now watch when I modulate. Is the frequency in use? Hello, test, hello, test. Is the frequency in use? You see that? I've got a lot of energy on the opposite sideband, and my audio is kind of not getting enough highs. It's very close to the low frequency range. Let me try it again. I'll show you what I mean. Hold on. I'll get it lined up better. Hold on. Lined up right there now. So again, 7159 here is about 2,700 kcs, 2.7 kcs. Is the frequency in use? Is the frequency in use? Hello, test. See what I mean? It's a lot of lows, not a lot of highs, and not a lot of opposite sideband suppression. So I've been looking at this, and I think I have found the solution. What I'm going to try to do, I'm not going to mess with the passband of the filter in the BITX module. Instead, I'm going to try to move the carrier frequency a little bit up in frequency. I guess you could look at it this way. I'm going to move it up this way so that I'll get better opposite sideband suppression. I'll have fewer kind of useless lows below 300 hertz in my signal, and I'll have less cutoff of the HF of the high frequency elements of the modulation of my voice. So I've been looking at the schematic of the BITX40 module, and I think I've figured out an easy way to do it. I'll tell you about that after I do my experiment. I just wanted to show you today what the problem was. Okay, now I want to try to describe how I approach the problem with the passband and the carrier frequency that I discovered when I looked at the BITX40 module signal from the Hodgepodge transceiver through my RTL-SDR dongle with HD-SDR. That's a mouthful. All right, here I have kind of a rough representation of the passband of the 12 megahertz crystal filter in the BITX40 module. It actually runs, the passband goes from about 11.996 megahertz up to about 11.999 megahertz. And the flat portion of the curve is here in the center. It's actually kind of a narrow filter, but if you consider the skirts, it's broad enough. It's about 3 kcs, 3 kilohertz from 11.996 to 11.999, with the flat portion covering, I don't know, about 2 kilohertz. Okay, so when I first looked at my signal, it appeared to me that, well, let me show you what the signal coming out of the balanced modulator would look like. Okay, now this here, the second drawing, is a representation of what you'd get out of the balanced modulator. There's a carrier frequency. Of course, the carrier is suppressed because it's a balanced modulator, and what is balanced out is the carrier frequency. But then you have the lower sideband and the upper sideband. Now, when you put that signal through the crystal filter, a couple things will happen. At first, here's the relationship I think we had at first. When I first took a look at it through the RTL-SDR dongle, I think we had a situation where they were lined up kind of like this. The carrier frequency was, okay, it was off the flat portion of the curve, but there was still quite a bit of passband in here. So what was happening was this portion of the upper sideband was getting through, and that's why you saw on the RTL-SDR display, it looked like what they would call energy on the opposite sideband. Also, I noticed that the high frequency components of my voice, which would be up in here, were not making it through the filter because it's lined up this way. See, the carrier frequency is about here, and the highs in my voice up to 3 kilohertz are beyond the passband completely. Not only, much of them are down in the slope, much of them are completely off, so they're completely cut off. So this is where you saw in the presentation from the RTL-SDR that a lot of the highs weren't making it through. Now, what are you going to do about this? So I know some of you will think, well, just move the crystal filter around. Well, that's hard to do. These crystal filters, they're made out of crystal, and the capacitors are in there. It's fixed. It's hard to move this thing. It's possible. It's much easier to move the carrier oscillator, to move this frequency and move this entire show up and down. So I figured that it would be better if I just shifted the carrier frequency up, move it up like this here, okay, and move it so that this carrier frequency was close to actually 11.999 megahertz. And I went in there and I added a couple capacitors to the circuit. I'll show you that in a diagram, but this is where it ended up. So now look at the situation. It's much better. So that whole opposite sideband is now being suppressed. It's not in the passband of the filter at all. Also, the highs in my voice, I'm getting much more highs in there. So maybe some of the really high energy, the high frequency stuff, the 2.7 to 3 kilohertz stuff is kind of suppressed because we're in the skirt, we're in the downsloping skirt of the filter passband. But it's much better than it was before, and I've got more highs in there. Also, a lot of the lows that are in here, say from 0 to 300 hertz, that are normally considered not too important for communications purposes, they're being suppressed because they're down here on the downslope of the crystal filter passband. Another thing that's going on, there might be some remnants of the carrier. The carrier might not be fully suppressed, and because now we've moved the carrier off almost completely off the filter passband, really off the filter passband, you'll get better carrier suppression. So this is what I did. I just moved it, and you'll see in the second video the results. I think they show that this really worked very, very well. I'll also like to point out that right now we're talking mostly here on transmit, but this also works on receive because the carrier frequency, we talk about the carrier frequency through the balanced modulator on transmit, but it's the same frequency, it's the same crystal, it's the same crystal controlled oscillator that produces the BFO frequency on receive. So when it's lined up this way, I noticed that when I did this, right away the receive signals sounded better. They sounded crisper because on the receive signals also I'm getting more highs coming through. So I think it was a very successful mod. It was a very satisfying mod just to put two little capacitors in there at the right spot and move that frequency by, I don't know what, I probably moved it maybe 300 or 400, maybe 500 hertz. And that was enough to straighten it out. And I think it's a lot better this way. So This was fun, and I hope you guys enjoyed this discussion of how this mod was carried out. I'll now show you the video of the results, and I think you'll see them. Okay, so I went in and made some changes to the BFO. I thought I was going to put a little variable cap in there, but it was too hard to fit it in, so I used two fixed 30 PF, 30 picofarad caps in parallel, put them in series with the capacitor that's in there, really basically replaced the inductor, because the idea is I wanted to reduce the amount of capacitance in the circuit, thereby bringing the BFO frequency up. I wanted to get it close to 11,999, and I thought that would take care of my problems. I was able with these two capacitors to get it up to 11,9991, which was close enough. You'll see the results here. I'll key the mic and then I'll speak, and you'll see the pattern has changed. We're still looking at about 2.7 kcs wide. I've got it lined up properly. Here we go. Hello test, hello test. Is the frequency in use? This is N2 CQR. So you can see, I think I've got the voice spectrum spread out in the passband a lot better, and I've got the opposite sideband rejection taken care of a lot better. And I think I'm also not wasting energy on the very kind of useless low lows below 300 hertz. Watch again. Is the frequency in use? This is N2 CQR. Yeah, the red line shows where the carrier, the suppressed carrier, is, and I lined it up by unbalancing the balanced modulator so to make sure that I was on the right frequency. Hey, but I think that's it. I think it sounds better. It does sound better on receive, and I think I'm going to sound better on transmit now too. So kind of a fun mod, making use of the RTL-SDR dongle. The best of both worlds. 7.3.